Dear students, I welcome you for today's lecture related to the conduction. First, we will understand the conduction in solid, liquid and gases. Then, we will see the basic definition of conduction. Then, we will try to see the different examples and then the mathematical equation associated with the conduction, and then we will move towards the thermal conductivity. So one by one, the experiment of conduction, that is a simple metal rod that is available, and on one end the wax that is attached to this metal rod, and on another end we are going to heat that with the burner. So as we heat the metal rod that gets heated, and on the another end that wax will slowly get melted. That is what happens in the experiment of a conduction. This is associated with the solid. But when you So one can say the metals are good conductors of heat because the metals have atoms inside them and lot of free electrons. So why these are good conductors? That is because the metals have atoms inside them and lot of free electrons. Now what these free electrons do? These free electrons, they move around and vibrate. It is the vibrations of the electrons that helps to transfer the heat energy from one end of the metal rod to the another end. Even if you will look at this figure, this is the dark red on one end where the burner is available, and it becomes gradually decreasing.
Excuse me, sir.
Yes.
Sir, the intensity of voice is breaking in between.
ओके, सगळ्यांनाच येतोय का प्रॉब्लेम?
Yes, sir.
I will close the video. So metals are have the atoms inside them and lot of free electrons. The free electrons can move around and vibrate. The heat energy is passed on by the neighboring particles vibrating along the metal. So these vibrations which are there inside the metal rod, which transfers the heat from one end to the another. Then conduction in non-metals, that is there. Non-metals are poor conductors of heat because they doesn't contain the free electrons. So there is no question of particles that is getting vibrating. So in non-metals, the heat energy is only passed on by the neighboring particles vibrating along the non-metals. No free electrons are there. So this allows a flow of energy from hot to the cold. It requires the more time. Now let us see one experiment related to the conduction in liquids. Now this is simple experiment in a glass tube. You are putting the ice and providing a certain gauze so that the ice will not move to the top. This ice that will be in the bottom of the test tube. Above that there is a water. Now once I am going to start the heating specifically to the water and not to the ice, means where I am putting the flame, that is more important in this experiment. Conduction in liquids we are seeing. So I have to only heat the liquid and not directly to the ice. So when we are going to heat to the water, its temperature will increase, and it may even increase to 100 degrees Celsius. But the bottom ice may not melt. Even the upper part of the water, which can reach up to 100 degrees Celsius, can boil. However, the bottom part of this test tube where we have kept the ice is not going to melt. So here we can conclude that the liquids are poor conductors of heat. Then coming to the experiment conduction in gases. So the liquids are poor conductors of heat, so they can be used as your insulators. Now coming to the conduction in the gases. From a flame, if you keep the matchstick 1 centimeter away, so that there is a gas or the air which is available in between the flame and the matchstick. So this flame that will increase the temperature of the gas, but it will not have the sufficient energy to ignite the matchstick. So that we can say the gases are poor conductors of heat. So these gases, they can be considered as the good insulators. So whenever the metals, very good conductors, non-metals insulators, liquids, they are also insulators. Non-metals and liquids, they are insulators. Then gases, they are good insulators. And best insulator is the vacuum. So there is no gas. Vacuum, that is going to give the excellent insulation. And that is why we are using the bottles, these thermos bottles, Milton bottles or other company bottles which we are using as the hot or cold water. There is a vacuum that is available in between the two layers. So this is the excellent thing, that is vacuum, that gives you the good insulation. So heat is transferred through a material. So what happens exactly in a conduction? It requires the heat that is transferred through a material by being processed from one particle to the next. So material, that is what is required. So particle and this material that physically doesn't move from one place to another. That is what is the limitation of the conduction. The physical movement of the particles is not available in the conduction. So particles at warm end moves faster, and this then causes the next particles to move faster, and so on. In this way, heat in an object travels from hot end to the cold end. So occurs by the particles heating each other, and so the energy that is transferred. That means the particles, they heat because of the vibrations. The conduction is the transfer of thermal energy without any flow of the material and medium, only the vibrations they are observed. This is the main process by which the thermal energy is transferred from one of the solids, and generally it is in case of your solids, we are saying that the conduction is taking place. In liquids or gases, we talk about the convection. That we will see in the next unit. So this is the conduction, which is because of the vibrations of the free electrons and no physical movement of the material. So main process by which the thermal energy is transferred is from one of the solids to the another. However, this can happen, conduction can happen in solids, liquids and gases, but to a reducing extent. So happens best in the solids. The particles very close together, because the particles which are, that we will see in different figure, the particle arrangements, the conduction does not occur very quickly in liquids or gases. So material that conduct the heat quickly are called the conductors. All metals are good conductors of heat. That is what we call the metals as the good conductors. Copper is the very good conductor. For example, the pan for cooking are usually made with the copper or aluminum bottom. That is why we are interested in the good conduction. कॉपर के बॉटम आते हैं, पूरा वेसल कॉपर का नहीं होता है, वो सिर्फ बॉटम ही कॉपर का होता है, रेस्ट ऑफ द वेसल दैट इज जनरली स्टील. So bottom that gives you the good conduction, it heats up the vessel uniformly at a faster rate. So when you heat a metal strip at one end, it travels to the another end. Okay. So the outer electrons of metal atom drift and are free to move. That happens in case of your solids. When the metal is heated, this sea of electrons gain the kinetic energy and transfer it to the metal. The kinetic energy gain hoti hai, and because of the gain of the kinetic energy, the electrons they move. So insulators such as wood and plastic do not have the sea of electrons, that is, the number of free electrons are not available, which is why they do not heat. Then the method of heat transfer, that is the conduction, the passage of heat from one part of a substance to the another part of the same substance, or from one substance to the another in physical contact with heat, without the movement of particle of either the substances. Then heat that passes from one part of a substance to the another part of the same substance. Okay. There are some substances such as the wood, wool, cork, which are the good insulators of heat. They are also poor conductors of heat, so they are called as the heat insulators. All metals, okay, check. Then conduction is a process whereby heat is transferred directly through a material with any bulk motion of the material playing no role in the transfer. So one can remember this definition, that is the process whereby heat is transferred directly through a material without any physical or the bulk movement of the material. That is what is happening in a conduction. Heat that is transferred directly through the material without any physical movement of the material. Those materials that conduct the heat are also called as the thermal conductors. Thermal terminology that has been admitted to that is the thermal conductors. The direct transfer of the thermal energy that occurs, the other terminologies or the different words for the same definition, we can see them. provided by the different authors. The thermal energy that occurs when the molecules bump into one another when two substances are touching. When the fast moving molecules bump into the slower moving molecules, it transfers some of its kinetic energy. So the closer together the molecules in a substance are, the more effectively they can conduct the heat. So it works well in solids such as the metals, where the molecules are closer together because they only have to move a short distance to bump onto the another. Because the metals, the only movement of the molecules that is there. But not as well as in the gases or liquids. The thermal energy always travels from hot to the cold. So the conduction, it's a direct transfer of the heat, touching or direct contact. Then the faster molecules, that gives you the warmer temperature. The slower molecules, molecular movement, that is relating to the cooler temperature. We have already seen the kinetic energy, which is measure of the temperature. The transfer of hot to cold from high temperature to the lower temperature. Now let us see the arrangement of the molecules in the solid, liquid and gases. These solids, they are regularly arranged. Liquids, there are more compactness that is reduced, and still in the gases, their compactness is reduced. So the particles that are very close together can transfer the heat energy as they vibrate. This type of the heat transfer is conduction. How do metals conduct the heat? Actually, what happens? Metals are the outer electrons of metal atoms are not attached to any particular atom. So outer electrons of metal atoms, they are not attached to any particular atom. They are free to move between the atoms. But when a metal is heated, the free electrons gain this kinetic energy. This means that the free electrons move faster and transfer the energy to the metal. So free electrons, they are more concerned for this conduction. This makes the heat transfer in metal very effective. Insulators do not have these free electrons. So flow of heat in a substance due to the exchange of energy between the molecules having more energy and the molecules having the low energy. Transfer of heat from one particle of matter to the another by direct particle to particle contact. Let us see the metal spoon in a pot of water being heated on an electric stove. So we are having the electric stove, the pot of water, and in that the metal spoon that is there. So what are the different steps that are associated with this process? So first, the electrical energy is converted into thermal energy by that electric stove. So that is what we will see this step by step, how this energy that is getting transferred. Ultimately क्या है? Electric stove है, pot of water है, and the metal spoon है. तो ये जो पूरी प्रोसेस है फ्रॉम इलेक्ट्रिक स्टोव टू द हीटिंग ऑफ द मेटल स्पून, it's a step by step heat is being transferred from one step to another, then from third, and subsequent process it is. So let us see that process. First, this electric energy is converted to the thermal energy by the stove. Then next, this once the thermal energy, the particles start vibrating and colliding. So this rapidly vibrating particles of the hot electric coil collide with the particles of the cool pot, which is there on the electric stove. On the electric stove, the metal pot that is there. So this coil first gets heated. From this coil, it is transferring the heat energy to the cool pot. So heat energy is transferred, causing the particles in the pot to vibrate. So pot में के particles vibrate हो रहे हैं. Then this rapidly vibrating particles of the pot now collide with the particles of the water at the bottom. So first step में electrical energy is converted into the thermal energy. This increased thermal energy that is transferred to the cold pot. This cold pot gains some kinetic energy. Electrons in the cold pot gains kinetic energy. They will increase the temperature. Then the around water that is available inside this pot will get heated. The water particles absorb the energy and vibrate and flow more rapidly, and its temperature increases. Now the energetic hot particles of water collide with the particles of submerged end of the spoon. So जो भी spoon का bottommost part है, which is there in contact with the water and the metal, that first starts getting heated. It's a step-by-step process. So this energetic hot particles of water collide with the particles of the submerged end of the spoon. तो spoon में कैसे जा रहा है? Is because of the water temperature that is increased, or the metal which is already in contact with that, because the metal का and spoon का means pot का और spoon का contact surface बहुत कम है. So it is what the water which is making this spoon to increase its temperature. As the particles of the spoon absorb the energy and vibrate more rapidly, the temperature of the spoon increases. As the particle at this end of the spoon absorbs energy and vibrates faster, they collide with the other particles in the spoon. Means पहले तो bottom of the spoon that is increased, and then slowly this particle electrons in the spoon, they will be transferring energy from hot end to the cold end, which is outside the pot. So this process of conduction is repeated all along the metal spoon until the entire metal spoon becomes hot. So this is a overall step process. We have to understand this detailed step process. पहले तो electrical energy से pot heat हो रहा है. Pot heat हो रहा है तो pot में के molecules vibrate हो रहे. They heat the water around that contacted surface of the metal pot. Once the water that starts vibrating, water molecules start vibrating, then they transfer the energy to the spoon. So bottommost part of the spoon that is getting heated. Then this spoon itself, inside the spoon, because of the free electrons from hot end towards the cold end, which is outside the liquid or outside the pot, that is transferring, and this process continues so that you will get a uniform temperature of this pool. Now this is the second example. This is the warm body that is there, and on the another end there is a cooler body. That heat flows from the warm body to the cold body. There is a cross-sectional area A. So let us develop the basic conduction equation which is required for our mathematical calculations. So the amount of heat Q conducted through the bar from warm end to the cooler end depends on number of factors. Now which are these different factors? And all these different factors, they are accounted for the development of the equation. Some may be directly proportional, some may be inversely proportional. So the amount of heat Q is proportional to the time T. कितना टाइम में वो हीट कर रहा हूं, because it is not directly you will get a hot spoon, so it requires a certain time because of the repetition of the process. जो भी हीट ट्रांसफर की प्रोसेस है वो रिपीटेटिवली मॉलिक्यूल्स कोलिजन हो रहा है, इसलिए हीट ट्रांसफर हो रहा है, एंड इट रिक्वायर्स अ सर्टेन टाइम. So time is one of the important factors. Then Q is proportional to the temperature difference delta T between the ends of the bars. So Q is proportional to the delta T. Then Q is proportional to the cross-sectional area A of the bar. That is the cross-sectional area A of the bar. कितने एरिया में से हीट ट्रांसफर हो रहा है और कितने लेंथ में हीट ट्रांसफर हो रहा है. And the Q is inversely proportional to the length L of the bar. So Q is proportional to A delta T, T upon L. Because we have taken Q is the amount of heat लिया हुआ है अपन ने. So this Q upon T, that becomes the heat transfer rate. Q upon T, that becomes the heat transfer rate. Q is the amount of heat. So note that the heat flow increases with the increasing temperature difference. As the gradient is more, the heat flow increases, that depends on the temperature gradient, increasing the surface area and decreasing the thickness or the length. So ये जो factors है, that is increasing the area, increasing the temperature gradient and decreasing the length L. So this Q upon T, which is nothing but the heat transfer rate, that will be A delta T upon L. Now in this figure, you can see the different molecules, and around these molecules, the vibrations of those molecules transfer the kinetic energy to the vibrations of collisions. So this is what the more number of vibrations, comparatively less vibrations, and still comparatively less vibrations are observed in this figure. So similarly, because at this left hand end you are having the higher temperature, and on the right, because the heat flow is from left to the right, that is what is shown in this figure. So this actually represents how the kinetic energy of the molecule that is getting transferred from one end to the another end. So what are the other examples? That is the metal handle of a saucepan, then your spoon placed in the coffee, then the food that is getting heated, then again these are your spoon example. In this one is the plastic wood spoon and the second is the metal spoon, that is what is shown. Then the cheese which is available in your birds, that is the cheese get melted. A piece of cheese melt as the heat is transferred from the meat to the cheese. So these are your different examples you can see. So that is now coming to the insulators. Materials that conduct the heat flow slowly or poorly are called the insulators. That is your glass, wood, plastic and rubber are the good insulators. Poor in conductors, that is the good insulators. Nearly all liquids, include the water, are poor conductors. Then the gases, including the air, are poor conductors that we have already seen. So that is what a fridge has insulation material around it to keep it cold, reduces the amount of heat conducted to inside from the warmer room. And however, if you will think of a fridge and a AC, there in case of your ACs, the room size is bigger, but the temperature attained is only around 20 degrees Celsius. However, in the refrigerators, the room size, the refrigerator sizes are small, but you can go up to the 15, 20, minus 15, minus 20 degrees Celsius. Now this is the wood chair and a metal rod that is available. Which material feels warmer and why? If you will touch to the metal and if you will touch to the wood chair, if you will touch to the metal, you feel a more cold as compared to if you will touch to the chair. So the wood feels warmer because it is a poor conductor. Now what happens when you touch to the metal? It quickly takes the heat from your body. It quickly takes the heat from your body. As a result, you feel the cold in your body as compared to the chair. So this is the same thing. Metal is a conductor and wood is an insulator. Metal conducts the heat away from your hand very quickly. Wood does not conduct the heat away from your hand as well as the metal. So the wood feels warmer than the metal. Color, that is also there. Some colors are good conductors of heat. Black, navy blue and the other dark colors are in heat quickly. So it's getting hot there because if you will wear the black shirts, so you require to that we already know. So conduction can occur by the molecular vibrations and because of the free electrons. Both molecular vibrations as well as because of the free electrons. So when heated, the free electrons move faster and diffuse it into the cooler part of the metal. The kinetic energy is then transferred to the molecules by collision. So coming to the mathematical form again, that is the heat flux, heat rate. First we will see the equation related to the heat rate. So this Q is nothing but the capital Q upon area. Here it is the unit having the watts. Watts is nothing but the joules per unit time. Watt is nothing but the joules per unit time. So this is the capital Q upon the T. The amount of heat per unit time, that is the heat rate. So which is equal to minus Ka dt by dx. And if you will divide this A to the left hand side, so it becomes your heat flux. And the proportionality constant, that is K, and it is nothing but the thermal conductivity, which is having the units of watt per meter Kelvin. K is the thermal conductivity and having the units of watt per meter Kelvin. And this dt upon dx, that is change in temperature with respect to the distance. So higher the temperature gradient, higher the temperature difference between the hot and the cold, you will get the higher heat transfer rate. But as the time progresses, that means initially the temperature difference will be higher, but as the heat transfers, heat progresses, this temperature gradient or temperature difference decreases, and as a result the rate of heat transfer, that also decreases. So molecules are in the constant motion. Their speed is proportional to the temperature of the object. When two objects come in contact, thermal conductivity now. Why do tiles or cement floor feel cooler than wood or carpet? The ability to transfer the heat is an intrinsic property of a substance. We have seen that example related to the chair and the copper rod. It is the ability to transfer the heat. So why some metals have the higher ability to transfer the heat? It is because of their thermal conductivity. The metals are good heat conductors due to the free electrons available, and that is the reason the amount of free electrons available that will make the more thermal conductive. So heat transfer is the energy per unit time, that is nothing but the power, which is watt. So thermal conductivity, that is the rate of heat conduction, is directly proportional to the area temperature difference and inversely proportional to the thickness, and the K is the proportionality constant. So this K is nothing but the thermal conductivity, a measure of the ability of a material to conduct the heat. K is the measure of the ability of a material to conduct the heat. That is what is a thermal conductivity. dT upon dx is the temperature gradient in the x direction. This is what we are considering in the x direction. A metal slab, on one end its temperature is 30 degrees Celsius, on another end its temperature is 20 degrees Celsius. Heat is flowing from higher temperature to the lower temperature. The length or the distance between these two ends is 1 meter. So this is what the temperature gradient is, the 10 degrees Celsius, 30 minus 20, and distance of 1 meter that is there. So now if you will consider the copper and the silicon, both having the copper is having the thermal conductivity of 401 watt per meter degree Celsius, and the silicon is having the thermal conductivity K of 148 watt per meter degree Celsius. So if you will calculate the amount of the Q heat transfer, this is talked in terms of a flux, watt per meter square. So heat flux, that is 1480 for silicon, and the heat flux for copper is 4010. The conditions are same. Only thing is that of the material difference that is there. And here the negative sign that is also there. So this is the heat is conducted